Hi everyone, I am Dr. Isamuda, Assistant Professor in the Department of Computer Science from Dr. SNS Rajalakshmi College of Arts and Science. Today now we will discuss about the concept Intelligent Rail Transit Prediction Maintenance System. This concept is a major role performed in our AI, that is artificial intelligence. This rail transit prediction, they automatically to detect the rail tracks. Now we move on to that introduction to intelligence rail transit predictive maintenance system. The first one is a transit system. They using a high reliability and safety measures. They your AI to predicting its the tracks and reducing of your breakdown risk. Everything it's done by an automatic process with the help of the AI techniques. Components using in our rail transit maintenance system. The first one is a sensor based condition monitoring. That is, sensor is your train tracked each and every distance they have set up as a Wi-Fi. Through that sensor, a sensor with Wi-Fi. The sensor is monitoring the your tracks and trains through the time. That is a wheel condition. Your sensor also it's automatically monitoring the wheel condition of that train, and brake system temperature and axle vibration, track alignment and signal system. The detection of the signal also through your sensor, that is automatic process without a manual intervention. Real-time train monitoring, that is a onboard diagnostic system. It is a live performance to the control of the centers. The automatically to detect the your train track movements and train condition monitoring. Everything it will be in a AI. Fault diagnosis using AI. Suppose your fault measurement in our rail transit maintenance system is through using our AI. It is an automatic process. Machine learning detect anomalies, that is a wheel flat spot, bearing failures and track cracks and overheating components. These are all the your fault diagnostic types. These are all the faults automatically to detect by the sensor. If the sensor fit by your the nearby the tracks, and wheel fault also identify, and any bearing failures and track cracks, everything it will be a automatic process. And track condition monitoring using the vision system, that is the computer vision systems. Rail tracks automatically to monitor and crack misalignment or structural damages. It is automatic to detect the damages. Predictive scheduling for maintenance. AI predict maintenance requirements and integrates with your scheduling systems to avoid the service distribution. They automatically predicting your schedules. For example, the single track they using the multiple rail transit means they automatically to differentiate the time scheduler of the each and every train, they using the predictive scheduling of maintenance. And a digital twin of rail system, it is a similar train operation and track conditions of safety analysis. Everything it would be done in a digital twin concept. It is a benefit the improved passenger safety and reduced service interruption, and the cost wise is a lower cost maintenance and increased operational reliability and optimized assessment utilization. These are all the benefits of rail transit. This is the mind map. The mind map is a intelligent rail transit is the core heading. Under that, sensor monitoring, AI fault detection, vision system. These are all be under your intelligent rail. The sensor is monitoring the wheel condition, brake temperature, and axle vibration. Everything it will be comes under sensor monitoring. AI fault detection is bearing fail, wheel flat, overheating. These role to detect the failures. And vision systems, track rack, and miscellaneous track damage. These are all the vision system. Design thinking based concept. That is the first thing is empathize, define, ideate, prototype, and test. Empathy is the user perspective to identify the problem and clearly to define the problem, and design the through with help of the sensor to clearly to define the design, and to develop a model and then test the system is executed successfully or not. Thank you.